10-3 tomorrow, depending on how much I like your book's examples.
Wait, is your phone on Do Not Disturb mode?
Yes, it was on it yesterday too.
What?
Yeah,
That's weird.
that's why I got confused as to how it turned it off. But it did, you're right, but I didn't see a missed call, so somehow but then I saw later a missed call. So confusing. Kiddos, what evens do we have from section 10.2?
22.
22.
Because we did 3.
So Sam's gone today, huh? He's gone yesterday too. Here he is.
The derivatives were such a pain.
For 22?
For all of you, just one.
22 is a pattern, wasn't he?
Yeah, this one wasn't even a direct.
22?
Yeah.
it was, look.
Oh. Oh yeah,
It's
but
a pattern.
everything else, especially like,
Oh.
there's one that was just horrible, god awful.
Okay, I found out for
26C.
number 1, how that one was a super horrible derivative. You can just do square root of 1 minus x and then plug in the x squared later. Apparently.
But what's the pattern for square root of 1 minus x?
Oh, just like do the derivative for that and then plug in x
Oh,
squared.
yeah, you could have done that.
Yeah.
That's true.
Because it at least makes it easier.
Yeah,
That's really good.
that's actually a really good idea.
Yeah. I saw it, it was
Because
on
you can
the
plug
slide.
and
Yeah,
chug.
you don't sit in and yeah, I can cut.
That's a really good idea.
And then
I did.
you find out later on, I think it's number
Kind of what we
27.
do with 1 over 1 minus x instead of 1 over 1 minus x squared.
That's like, then 27, it basically told you to do that. Because it did the Taylor series for square root of 1 minus x, and then it said use it to do 1 minus x squared.
Oh, like it really did. It would have been nice if that one would have come first.
Right?
But it's okay. Lame sauce. Did we already check number 22?
Yes.
Okay.
That was nice.
Third degree Taylor polynomial approximation 4.848 and blah 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 derive blah 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 plug in 3.52. Approximately though, right? Did you guys put little squiggles? If you put f prime of 0.2 and f of 0.2, make sure you have squiggles. If you don't have squiggles, what's the
Shoot.
number next one? 24. Oh, where is he? He's up there. 24A, you would have had to locate the appropriate term or find the pattern. The pattern's probably the easiest one. I think we started this one together, didn't we?
We actually did it together like.
Go team. So the 10th derivative ends up being 10 factorial over 11 factorial, long story short, 1/11th, which is the pattern that we found. For letter B, just multiply the series by x, and so everybody just pops up one. And then for C, wait a minute, what? How do you
I know.
figure out C?
I didn't, that's the thing.
Oh, sorry. 4, 2, 3.
Thank you.
5, 4, 3, 2. Zoop, zoop. What does this top one look like?
What's you?
1 over n?
No, what's his
Plus one.
pattern? Who is this?
X to 1.
Over.
Oh, the whole thing?
Who is he?
Who am I? What?
What is up?
Don't worry. Today we're gonna finally write our endeavor card.
Yay.
Technically, it's not supposed to come until kind of a little bit later, but isn't it just e to the x?
Yeah.
So if it's just e to the x, then what happens when we multiply? Oops, there we go. When we multiply everybody by x,
We multiply by x.
you guys ended up with, it was x plus x squared, right? Over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. Hold on, this begs the question, wait a minute, is the beginning one really e to the x, or is it just close to e to the x? Okay, I can't actually say that's e to the x. Why not?
Because there's,
Can you
it
say
starts
the
with
x
1.
over x?
It's x to the 1 over 2, x to the 2 over 3, x to the 3 over 4. So that's not actually e to the x, to be honest. We're not exactly sure who that is, but it does look like e to the x.
Can I make it e to the x over x?
And once we multiply this dude by x, now does everything line up? Yes, but what's missing that e to the x should have?
The 1.
So hence we can say g of x is equal to, hey, that's e to the x, except the 1's missing. Dun 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 dun. So I'm not exactly sure who that original function is as far as a rational function or an exponential, logarithmic, trigonometric, I don't know. But take that original Maclaurin series, multiply them by x, and then you get e to the x, but the one's missing, minus 1. Dun 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 dun. Does that make sense? So going back to number 24. Boop.
That was evil.
It looks evil because it's like, oh no, that's magical. Except if you know e to the x, that was e to the x, just the 1 was missing, minus 1.
Yay, minus
But
1.
we didn't know, that's the problem.
Ah, but hopefully after we make it on our Endeavor card, even though I have written it down and said we need to memorize them, hopefully now we will be a little bit better about that. What's number next one?
26.
On to the next one.
Here he is.
26B.
Think about the series 1 over 1 minus x, and then think about times 2, and then think about plug in t squared. Think about the series 1 over 1 minus x, multiply everybody by 2 and plug in a t squared instead of a t, you end up with the final series here. Letter B was saying, given a clue, I think, right? Capital G of 0 equals 0. We have a clue. We can find the general function by integrating from 0 to x. And so all we gotta do is integrate term by term. But plugging in x instead because they said capital G of x. Do you guys see how with that question, who was that, number 26? Doesn't this look a lot like some things that show up on an FRQ? G is equal to an integral, but now with Taylor-Maclaurin's, they can ask us something very different than we're used to. Instead of giving us like a graph of the derivative or something, they can go into Maclaurin's.
Thanks a lot, guys. Thanks a lot, Taylor. Thanks a lot.
You guys check it okay? Do we have any more?
Yes.
27 was awful, but I don't know.
40.
40 and 42?
Oh, I got those.
40, A. 40 should be A, 42 should be A as well.
I wasn't sure. Hold on. For 41.
I had the book open, oh, I still get it. Oh, for 41, how to do it? Hold on, let me check.
Oh. Just plug into it. Got it.
Are we okay on 40 and 42? I'm going to go back to 27 real fast to make sure we understand it, but the multiple choicey ones, any questions?
Just
No.
41, but I think I got it now.
41. I hate the ones where it's like, find the first 4 and every other one is 0. And it's like, ugh. I cannot divorce.
That's such a pattern.
Yeah, that's the thing. None of them had a viable pattern. The pattern was any pattern that I tried to find. I couldn't find one, and I spent like 10 minutes trying to find it.
Can you give me an example besides number 1?
Oh, that's what I had the problem with. What? Sine is x minus x cubed over 3. So how can you find the fourth? That's what I didn't get.
But remember, the fourth doesn't mean,
Isn't it to the fourth power?
Yeah,
But it's should be x to the 1, x to the 3, x to the 5. So there is no fourth.
no, because it's sine of pi over 2, not sine of x. Or sine of 0, I should say, sorry.
oh, right. You were thinking of the Maclaurin, and the Maclaurin is centered at 0. This one was centered at pi over 2.
So you can't use sine of x as like the first thing. Okay.
Yeah, that's what I did and I messed up and I was like,
You can only do our special, and then we'll get back to our Endeavor card that's chilling.
Got it.
Maybe we should add a little note for ourselves, huh? We'll
Yeah.
do centered at 0. Cause if it's centered anywhere else, we can't just add in the x minus a to the original because we're missing the f prime of a on the outside. Does that make sense?
Yeah.
And the f double prime of a, et cetera, et cetera. Good question though, good catch. But number 40 we were okay on, we got it all right?
Yeah.
Cool. Alright, let's go ahead and go peek at number 27 then. Good job, kiddos. Because I actually had him copied down, because I got all the long answers copied down. And 27 you were able to check last night.
It was awful.
What was awful about it?
The part C, the derivatives, when I got to the fifth derivative, it was just like, it took up like a good fourth of the room it took to do C, which took a half a page.
Wait, it shouldn't take like any room.
Yeah, why didn't it take that much room? Hold on, what'd you guys get for letter A? Let's just work it out real fast.
A lot.
What were you supposed to do for A? You're supposed to find,
G prime,
First four
G double
terms.
prime, G triple prime,
First four to offshoot. I only did it
or F
two.
triple prime.
right? But then what did you end up getting? Let's just use your work from last night.
2 plus 0 plus 2t squared plus 0 plus 2t to the 4th.
T for A?
1 plus 1/2 x minus 1/8
Oh,
x
dough.
squared, and then plus 1/16 x cubed.
I was looking at 26, sorry.
Oh, okay, that makes
Yeah.
more sense.
1/16 x cubed, yeah. She's right.
And the nice thing is they did not say, if you guys noticed, they did not say the general term. Yay, go team. We got 1 and 2 and 3 and 4 done. Letter B, how do we find all this information for G? Find G prime, yep. Find G double prime, yep. Find G, no. Why is none of that necessary?
Because we can just
Integrate.
derive those.
Just plug in x squared.
Plug in x squared, because look at the comparison between this guy and this guy, right? If you've already done all the work for f of x, which is a simpler derivative to take, because this guy's going to have a u prime, right? We can go ahead and say, sweet, g of x is just f of x with x squared plugged in. Hence, you should have gotten, hopefully, 1 plus 1/2 times x squared, right? Minus 1/8 times x squared is x to the 4th, plus 1/16 x squared cubed, x to the 6th, etc. Actually, they're not saying this series. Wait, the first 4 terms in the series. That's okay. Now letter C. Find the first 4 non-zero terms in the Taylor series at x equals 0. Wait, haven't they all been at x equals 0? Hence why we've been doing what we've been doing. Okay. For the function h such that h prime is equal to 1 plus the square root of 1 plus x squared. Well, if that's what h prime equals, then kiddos, how do we get h?
They tell us.
Yeah. They don't say integrate specifically though, do they?
No,
No,
they just hand it to us and we keep deriving.
Not deriving, integrating, right?
What?
Because we can say h of x is equal to the integral from 0 to x of
Root 1 plus
g?
Yeah.
Yeah, of g of, we'll just make it t for right now.
Okay.
Now, hold on, why am I gonna do 5 plus on the very beginning before I do anything else?
So the first term is
Yeah, remember real quick before we get too much further? H of x is not equal to the indefinite integral. What is equal to the indefinite integral?
5.
H of x minus h of 0, right? Why am I saying g? Because h prime is equal to g, yeah?
whoa. That's functionception.
It's a little bit crazy, yeah, because they gave us g and they said all of a sudden, hey, wait a minute, that's h prime, and you're like, oh, okay, who's h? So in order to solve for h of x alone, then I have to go ahead and say h of x is equal to h of 0. If you want to, we can do this, if it makes it a little bit nicer. H prime of t dt. We're just adding h of 0 to the other side, so we have 0 to x of, who is h prime, g of dt. Where does that lead us to? H of x is equal to, who's h of 0? 5, plus the integral of who? The series. What series? Oh, the one up above. Alright, let's integrate the series. And integral of 1 is x. Integral of 1/2 x squared is x cubed over 3. 1/2 and 1/3 makes 1/6. Is that okay? plus, oh, sorry, my bad. It's 1 plus and then minus?
Yeah.
Bum, bum,
That
bum.
is weird. Let's see, where am I? Minus
Minus.
x to the 5th over
40.
5 and 8 is 40. And then we have to do one more, so plus x to the 7th all over, 7 times 16 is 112, is that right?
Yeah, 1/4.
Oh, I didn't do that far.
Dun, 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 dun.
So on this one, you just had to do, wow, I went the hard way around. You just had to find the Taylor series.
Oh, the first 4 non-zero terms.
integral.
Sorry, real quick, we only have to do that many.
Yep.
Oh,
That's good.
Oops.
That far.
so we should cut that guy off.
So for this one, you just have to
Yeah.
realize that you have to do the Taylor series for the integral of g of x.
Yes.
Okay. That, wow, that could have saved me like a good half a page of paper.
Might have.
Coulda, woulda, shoulda.
Well, it doesn't really matter if I use the whole page
Woulda.
anyways.
It's okay, live and learn, live and learn.
Mm,
Does that make sense now?
yeah.
Yeah.
Yay, next chapter, next chapter.
Would you?
New section inside.
So, question kiddos, this is similar to 2008 BC exam, version B number 6 FRQ. Should we be able to do this?
Yeah.
Should we? Yes.
Yeah.
Well, not D, because we don't have to do that.
Well, hold on, letter A, write the first 4 non-zero in the general, got it. Does the series converge to f of 1?
Yeah.
Are we going to think about the radius of convergence, because who are we actually going to think about in making letter F?
R is-
Derivatives? No. Yeah,
R is negative x.
true? So r is negative x squared, so then we're going to think about x is between, oh, isn't it still going to be 1 and negative 1?
Yeah.
And so yeah, we did it. So it converges.
So when evaluated at 1, is it going to converge?
No.
No, because the radius has to be in between but not equal to 1 or negative 1, right?
But isn't it not? Because isn't our IOC less than, not less than or equal to?
Exactly, that's why letter B is no. Does that make sense? It'll diverge because it's not in the interval of convergence.
Oh, it actually was on my level. Question.
There you go. Letter C, the derivative of arctan, hey, wait a minute, kiddos, use our knowledge from number 27. If they tell us the derivative of arctan is 1 over 1 plus x squared, which we should know,
Oh, yeah.
then how do we figure out arctan?
Integrate.
Integrate. Right?
So we have to write the terms out for
So you
that.
can say arctan of x is equal to arctan of 0. What's arctan of 0?
0.
Uh-huh. Of our Taylor series up above, f of t dt. Does that make sense? So we're going to integrate term by term the series that you would find in letter A, and then letter D. Use a series found in part C to find a rational number A such that is less than 1 over 100.
So the error approximation.
Yeah, because it's an alternating series.
Has something to do with error. It is alternating. How come? Because you're multiplying by a
Negative.
negative. So how are you supposed to find a rational number A such that something is less than 100? Huh? Ooh.
So S sub n. What is it?
Isn't that the exact? Arctan of 3/4? If that's the exact, then we just have to, for this guy, don't we just have to plug into our Taylor series?
Where would you plug that in there?
Arctan, that's letter C, right? We find the first 4 non-zero terms of the Taylor series. So let's go ahead and find that real quick. Letter A, it's just a geometric series with, starting at 1. What would be our next term?
Minus x squared.
Yeah, because r is equal to negative x squared. So we could do minus x squared plus x to the 4th.
Over.
First 4 non-zero terms, right?
Yeah.
Minus x to the 6th plus dot dot dot. And the general term of the Taylor series.
Wait, what
That'd
happened
be-
to the factorials?
since we know this.
Oh, it's a geometric series, so I'm just multiplying by negative x squared. I'm not actually using the Taylor series definition.
Okay.
Or I should say Maclaurin. Does that make sense?
Mm-hmm.
Okay. Or you can think I'm building upon this guy, and this guy doesn't have factorials. 1 over 1 minus x. I could say x to the, let's see, negative 1.
What is it, x to the 2n minus 2? No, just to the 2n.
I need to do n, right? And then times, struggle. X to the 2n. I used to do 2n, right? Starting at n equals 0?
Oh, yeah, because it's starting n.
So n equals 0, the negative 1 would cancel, n equals 0, anything to the 0 is 1. Good, and then I got it. And then it says series, right? So if I'm doing series, I need to keep on saying dot, dot, dot. Does that make sense? Doesn't say polynomial, it says series, so add the dot, dot, dot at the end. Letter B, we've already talked about how it's not going to converge. Long story short, the interval of convergence is the radius, shouldn't say the radius, x needs to be within, not including negative 1 to 1. Dot, 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 not at x equals 1. Okay, you guys can fill in the blanks. Letter C. So how do we find arctan? We already said arctan of 0 is just 0, so we have arctan of x is equal to, integrate term by term, integral of 1 is x, integral of x squared is 1/3 x cubed, integral of x to the 4th is 1/5 x to the 5th. Integral of x to the 6th is 1/7 x to the 7th. It just says the first 4, not the general. Whew, good.
The first 4, not, wait. So get, okay,
So
tell
since it
us.
says the first 4, I need to put estimating squiggly lines, right?
So R10 is about that, right?
Mm-hmm.
So why can't you just, because the arctan of x equals arctan of 0 plus integral of 1 over 0 to x, ft is confusing. Why can't we just skip to C, answer part? Like,
I did. I'm pretty sure I just wrote it.
no, but like when you wrote arctan of x equals that, it confused me. I was like, wait, what?
Because it's integration is net change.
Because we're solving for arctan. Right? We're trying to do the series expansion for arctan.
F of b minus f of a equals the interval from 0 a to b. And then, so if you want to solve for arctan, you have to add the f of b over.
Which was really important in our number 27, because we ended up having to put a random 5 in front of our interval. So in this one, arctan of 0 was 0, so it didn't make a difference. But in the one that you're looking at right here, h of 0 was 5, so it did make a difference.
So it'd be better to do it that way, right? And then
Showing the work this way will always get you to the right answer. Skipping, like what you're thinking of doing, might sometimes be wrong if the initial is not 0. Does that make sense?
Wait, isn't arctan? Is it always 0?
Uh-huh. Because remember arctan's graph?
Could it be 5? No? Oh, because it's restricted? Never mind.
Just do the, it's integral is net change, but the integral part from 0 to x, that's
It's basically a fundamental theorem of calculus
the
applied.
integral of the series, right?
Huh?
Like the integral from 0 to x of ft is the integral of the series, right?
Yes. Because f of t we wrote, or we figured out as a series. We figured out as a series. Where are we at? Oh, letter D, finally. Whew. Okay. Use the series. Now we have the series right up above us, right? To find a rational number A such that, and we already talked about this is going to be the estimate, right? Estimate means it's some sort of Taylor polynomial, perhaps. I'm trying to find a rational number A. A rational? Minus arctan of 3/4, so we know when x equals 3/4 less than 100. This is an alternating series, right, kiddos? Okay, so if it's an alternating series, then I know that wherever I stop, the error will be less than the n plus first term, true? So, question. I need to go ahead and say, hey, what a sub m plus 1 for the series up above is going to be less than 1 over 100, right? Well, how do I do that? We'll have to think of, sadly, I know, it's a bummer. What's your nth term?
So
Oh,
negative
-1
1 to the n times x to the,
2n minus 1.
are we starting at
You're
0?
always starting at 0, yeah.
2n? Oh, n plus.
Wait, does that work though?
Or,
No.
It should be
No,
2n.
Must be 2n.
I need odd numbers, true?
Yeah.
so over n plus one, right? Or 2n plus one, yeah, 2n plus one.
And then, aren't I gonna have the exact same number down below?
I think there's like a, the
So we have the odd numbers starting at 1, 1, 3, 5, 7, which could be 2n minus 1, 2n plus 1, but 2n plus 1 works for our case. So then if I need the n plus first term, what would I do? Absolute value says forget the negative 1, right? So I can go ahead and say x to the,
2 times n plus 1, or so it would be 2n and then 2, so 2n plus 3. And then, and then cross multiply.
wait a minute, I have too many variables.
3/4, plug them in, plug them in.
So what is 3/4?
That,
Mm-hmm. So can't I go ahead and say from this, kind of like our such that? That's what I'm plugging into arctan. So I have 3/4, so 2n plus 3, all over 2n plus 3, is less than 1 over 100.
2n plus 3 is less than,
So I can say 100 times 3/4 cubed times 3/4 to the 2n is less than 2n plus 3, right? Now what can I do?
9 over, no, not 9, 27 over 60.
maybe 64 and 27 to multiply through the other side.
Oh, I'm just trying to put together the one, I think just the 100
I
and
multiply
the
the 100,
3/4
right?
cubed. Uh-huh. So then 64 and 100,
You could do 2, and then that would be 15, 32, and then
16 and
2 again.
25, can we do that?
Sure.
16 and 25, no, 4, 8 and 25.
4 goes into
32,
64,
yeah, you're right, my bad. 25, 32.
16 times, and then 25 times. Is anything else reduced? Ugh.
And 25 times 27.
That'd be 27 quarters. Ugh. 27 quarters divided by 4, because each of those make 100, right?
So almost 8, no, almost
6,
almost 7, right?
yeah. So
Maybe
675?
6 and 3/4? Yeah.
So we have 675 all over 16 times, why am I saying 9/16 to the n?
Because we took the square root. And then
Now hold on,
subtract 3, no we can't.
which problem is this, number 6? Ooh, that's a non-graphing calculator problem? Struggle, that's rough.
And then just guess. Put 7 just for fun.
We could just guess, I'm just surprised that they would have us guess. I wonder if they made it harder than the actual FRQ.
Use the series found in part C to find a rational number A. So we have to find an n that the error will be that much, and then use that n and plug it into our series, and then find that a. Wow, that's a long process, not gonna lie. I feel like this would take forever on the AP test. With the time limit.
Yeah, there must be a shortcut that I'm missing. Either that or they made it harder, because with the graphing calculator, we could solve it pretty quickly, right? Just
Yeah.
graph the two and figure out where one's below. I mean, 0, 1, 2. 16 and 16, is that 256?
Oops.
Let's come back to this. There must be some sort of shortcut that I missed, because that process is a little bit too intense. More intense than I would have expected. Because even to plug in like 3/4 there, obviously the first term, I need something bigger. 3/4 there, that would be 3 cubed is 27 over 64 times 3. So I'm just thinking about, like, you could just estimate it and plug in. So that'd be 27 over 64 times 3 would be 192. Which is not less than 100. If I was to plug in 3/4 there, yeah, those numbers are getting high, those calculations are getting high. Not impossible, just messy. Alright, we'll come back to that, let me go check out if there's some shortcut that we missed, but otherwise I think we have the right process down, it's just having to solve that. We'd have to actually plug in 3/4, like my mind is seeing like this math, using logarithms, yeah, we're not gonna be able to do that in our heads. So if we were gonna start testing stuff anyway, we could plug in 3/4, it's not gonna be less than 100. Plug in 3/4, it's not gonna be less than 100. I'm guessing maybe that one might be less than 1 in 100. And then we could go ahead and just steal the first two terms and then plug in 3/4, but I don't even have a calculator and I don't know if you guys do either.
And
Let's go
you did it
ahead.
in the name of Jesus.
Let's go ahead and enter our notes, let's write down our endeavor card,
Who wants to write this? You have to think it?
but I have no idea what number we're on. 20
I'm not sure
something.
my notes are.
It's been a while since we had an endeavor card.
And
Let me see if I can go back and find our last endeavor card.
I think it's 25.
Sounds good to me, does anybody have a better guess?
Where are they,
I don't think we've had one this chapter specifically, just because a couple things are coming.
where are there one of these forever cards?
Nope,
Oh, then it's 23.
it's 23.
What about definition of power series? None of that? You don't want none of that?
We technically could, hold on, where's definition of power series? Don't need that. No, no definition of power series. Taylor McLaurin? No, let's not make endeavors out of that, because we're gonna make them out of the Taylor McLaurin series that are coming in next section.
oh,
Ooh. So wait, this one, which one, sorry, endeavor number
20, she said.
23 maybe? Okay. As you guys get that, do I have any calculators?
I have a calculator if you want it.
yeah,
Hold on, I think this one's closer for me to get. If anybody sees Lily R, for some reason I have a calculator that has her name on it. I think there are technically 2 Lily R's, so I don't know which one. But one of them's
Ramsey and Lily
missing.
Robles?
Yeah,
Is Ramsey?
if one of them's missing a calculator. None of them are in my class, so I don't know.
Is Arabella in your class?
Uh-uh.
Okay, is,
I mean, some
Violet
of
in
the
your class?
group, yeah, some of the group is in my
So
class.
maybe it's, yeah, well, it's depends with.
Maybe they were borrowing.
Yeah.
I remember Mr. Shanks didn't let us borrow calculators for tests.
Well, Mr. Shanks, no one to teach you.
Did or didn't?
Did not.
That's a good thing.
What are you supposed to do if you don't have a calculator?
Borrow.
Exactly.
Exactly.
You know, he said because you could just go scroll back up on someone's dependency at work and cheat that way.
That is true.
Well, Mr. Shane's gonna fight me.
I feel like that would take more time than it's worth. Like you have to find the right
I don't
one.
think so.
People are desperate.
Didn't he give out like 7 different tests?
Yeah. He was like super paranoid about,
Cheating.
yeah.
Which
I
probably
never
is a good
underst-
thing.
But I never understood that, like, if you give different tests and you don't know who knows what, you know what I mean? And like, cause like each test, one test might be easier than the other.
Yeah, that's true.
Yeah, it is hard. It's very hard.
So you don't really know who's actually
Whew.
doing the work and who's not, and who's getting an easy test. who's
On the
not.
one before, we would have had to go to n equals 9.
Yeah,
Huh.
yeah.
Yeah.
Or would have been the 9th degree, so we would have gone back one
So we would
to
have
the
said
7th expansion.
AP graders are evil.
Wait,
It
why
has to be
7th
an easier way
expansion?
for that.
Doesn't 9th degree mean when n equals 9?
Yeah.
So when n equals 9, n equals 7, because it's like multiplied by 10.
Well, but in my mind, I was thinking of the nth term, so then technically 9 would be the n plus first term, if that makes sense. Okay.
What makes these guys so special, Steve?
Because you guys have been using them over and over and over and over and over again, so you need to memorize them.
Oh, okay, sure.
Now, who's missing?
Not me.
I think our book gave a couple more. For instance, what if we had 1 over 1 plus x? Our book says memorize, and what do I say instead?
Just the negative. Just
Plug in a
change the sign.
negative x, which means it's going to alternate, right?
Yeah.
Etc. What about ln of 1 minus x? Book says memorize, I say, you're right. Why? Who's he related to?
That one.
That guy.
Could be this one, or it could be this one with a negative x plugged in,
I
right?
thought that's what we
No, but it's the 4 is the derivative of that, so you can just integrate 4.
Yeah, you can either integrate 4 or just plug in negative x to 5. I'm not sure which one you prefer.
I like 5. but
I like 4.
So integrating 4, you end up with x plus,
Yeah, just like, I don't know,
X squared
5
over
you just
2
change the sign, don't you?
plus x cubed over 3,
Yeah.
plus x to the 4th over 4.
5 you just change the sign, you go negative, positive,
all
negative,
positive.
positive, negative.
Right? Oh, no.
No.
Yeah, it's opposite.
Instead of being positive, negative, it's negative, positive. But whatever.
Anyway,
You can
so,
do what you can do.
anyway, long story short, we're supposed to start on this today. 10-3. Lagrange. We're going from Maclaurin. The Maclaurin polynomials. We're going from Maclaurin to Lagrange.
Lagrange.
Changing nationalities a little bit.
What does that mean, Joyce?
It's a name.
Does it have to mean something?
Lagrange airbound.
Does that mean like the garage?
I don't think so.
Oh.
But Joyce, if it does mean something, let us know. I
And if
guess
it doesn't-
L'Hopital meant something, even though it's a name. Going back to Taylor polynomials, well, in our book, we haven't really gone far. Last year's book, we went away for a little bit. Going back to Taylor polynomials, what do you guys think R stands for?
The radius.
Nope.
Big R, it stands for big R. The sum,
Which part?
Riemann sum,
Oh, I didn't do those.
remainder.
Remainder, and by remainder, I mean
Integrate 4.
error, right? T sub n, isn't that a Taylor polynomial?
Probably.
So we could say a Taylor polynomial
How do we know it's Taylor polynomial?
approximation. We use P sub n, it's some sort of nth something, and whenever it's an nth, it's a finite, and if it's finite, then it's gonna be an approximation. Does that make sense? It could be the 5th or the 3rd or the 2nd or the 7th. It could be the 100th, and it's still an approximation. Remember, converging is an infinity thing from that.
So French people use Z and T instead of P and X. Where's the Z coming from? I don't like
Z is special.
it. Oh,
F of x is the actual, right?
I see.
And besides this, doesn't this look a lot like the n plus first term possibly in a Taylor polynomial? Well, that's kind of cool. It's an n plus first, but this isn't necessarily for an alternating series. So maybe error is beyond, or there's something else we can do with error when we're dealing with series, even if it doesn't alternate. For an nth degree Taylor polynomial, R sub n equaling x or error is given by, basically I would put in here something like, and I think our book does originally, something like A. But here's the problem. That's true for some A within x to c or c to x. Kind of depends on which one's smaller, which one's bigger. And so we can think of Lagrange error bound in some senses as the worst case scenario. Basically, it has been proven that the remainder or the error is going to be for some x value within x to c, whoever x is that you're trying to approximate. I need to double check this. Our book puts an open interval. I've seen others that put a closed interval, so I need to kind of figure out what's going on there. But we'll say C as where it's been centered to x. It could possibly be backwards if x is below C. But since it's going to occur somewhere in there, we're going to choose the z in that interval that maximizes the n plus first derivative function.
Why is there an absolute value into the absolute value on the yellow part, but not in the, like when the first time you said it, you're gonna have the absolute value.
I think it has the same absolute value on both parts, right?
Oh, I just missed it.
Oh, okay. The worst case scenario. Alright, kiddos, here's the long story short. I wish we had gotten farther and we didn't. We're gonna continue on this tomorrow. The nice thing is we're not gonna have questions hanging over our head from section 10.2. However, I do have a chapter 10 review kind of AP packet-ish sort of thing. It's actually copied off, but it's back at my desk, and for me to try to go get it right now, I'm not really feeling it. So, if you guys want it, because you're gonna have extra time tonight, you might not